All right. So now that you have managed to get all of your data presented in a table, what we're now going to do is the second step in this process of presenting your data, and that is to construct a graph. So I am going to stick with this incline problem. I'm going to create my graph, and when I'm dealing with time, my time always fits on this axis. Okay? So I'm going to write the word time, and I'm going to give its unit. I'm going to write the word displacement, and I'm going to give its unit. Okay? Those are critical to your graph. Okay? The other thing that is critical to your graph is make sure that your origin is at 0, 0. Do not crop your graph in a way that that presents your data in a different fashion. Now I'm going to tell you this statement. You can be offended by it. You can not be offended by it. I don't care. Pie graphs are for newspapers. Bar graphs are for chemistry and biology. Scatter plots are for physics. We will always build scatter plots when representing data. Okay? The other sciences can use their little fluffy graphs whatever way they want to. But we are physicists. We present data in a mathematical fashion. We're not trying to convince one person of one thing or another by going, ooh, imagine what my bar graph looks like. Instead, we are just here to present the data. Okay? Now, here is why you need 5 data points. If I were to put 3 data points on a graph, I do not know what the behavior of that graph is. I can put these 2 points like this. I do not know what the behavior of that graph is. I can put them like this. I do not know what the behavior of that graph is. I can draw all sorts of functions that kind of get those data points together. So 3 data points is never enough. Okay? So you have to have a minimum of 5. 5 is the best way I wouldn't say the best way. It's the bar for the lowest possible number of data points to get kind of a perception of how that graph behaves. So I am going to put a series of data points on my graph that look like this. And it looks like I've got myself a problem because my data looks like that. Okay? Do not force a line other than the behavior of the curve. Okay? If this was my graph of distance versus time, actually my graph of distance versus time would look slightly different than this, then your next step is to linearize the data. And how I linearize the data is dealing with either my distance or my displacement or my time. And I know in this experiment that what I would want to do instead of this, I would want this to be with respect to time squared. That is me linearizing my data. To take a non-linear fit and turn it into a linear fit by adjusting what I'm plotting. Okay? Yeah, this graph would not work. Okay? So now that I have linearized my data, I'm going to replot my data points because now I'm doing distance versus time squared and not distance versus time. And I'm getting something like this. Okay? Rule number 1. This is not a data point. You are not forcing a line through that point because it is not a data point. It does not represent any data at all. It's representing an assumption, and sometimes that assumption is incorrect. There's the other data point, by the way. Okay? Rule number 2. You are not trying to find what the image is hidden between your data points. Do not connect your data points. Okay, you're not trying to determine whether it's a giraffe or something along those lines. Okay, instead, you are going to have your data. I'm going to make it a little bit smaller so I can get on there. And you are going to put in your best fit line. The way best fit line is described as an equal amount of weight above as below. And you're not actually going to calculate the weight. You're just going to approximate it. If I were to draw a line like this, How we define weight is basically how far from the line these data points are. And you can see that I'm slightly off there. There's a little more weight underneath than there is above. So I might make a little bit of an adjustment on that line to get the right weight. Now, this is how we did it in the 1970s. This is how we did it in the 1850s. We now have devices called computers, and computers will do this for you. I know, as a matter of fact, you can go into Google Sheets and you can insert a chart and go in there and hit Add Trend Line, and that trend line will drop that data wherever it's supposed to be. But the idea of that line is that there's an equal amount of weight above as below, which just simply means the total amount of distance from the data points to the line, the total amount of distance above the line to the data points should equal the total amount of distance below to the line to data points. Okay? That's kind of a confusing way to do it, but nevertheless, you are going to use a computer anyway, so you really don't need to know the nitty-gritty on this. Now, this is something that IB does that I think I've done it once in reality, and I mean reality as in I performed an experiment and I needed to do this, and that is to get the min and max slope. So I'm going to go ahead and I'm going to put my data down. Here is my data. I'm going to put my trend line down. Okay. Now, min and max slope is done this way. So I have this data point here and I have this data point here, which are my leading and my trailing data point. I'm going to take that data point, or I'm going to take all of my data points, and I'm going to slap an error bar on all of my data points. Now, we only need the vertical error bars. We do not need the horizontal error bars. If you want to put the horizontal error bars, feel free to do it. But the vertical error bars are what I'm going to do. To do this, there is a function in Google Sheets that do this. Same with in Excel. You just give a value for the error bars, and all the error bars go on there. And the error bars are actually determined by your percent uncertainty. Your total percent uncertainty for that data should represent this, and it should represent that. Okay? Now, the next thing is you're going to get this data point here, and we're going to call that data point stupid point 1. And we're going to take the data point here, and we're going to call this stupid point 2. And we're going to insert another line. We're going to make sure that this other line is of a different color or a different style, so that not to confuse it with any other, not to confuse it with real data, I should say. So, oh, my red does work. I'm going to connect that data point to that data point and have it hit the axes. Okay? That's going to be one predicted value. That's going to be my maximum slope. And then I'm going to create another set of stupid points. I'm going to take stupid point 3 and stupid point 4. And I'm going to now connect those by creating yet another line. I'm going to use red. You could use a different color. I kind of actually recommend you use a different color. I'm going to connect those data points. Okay, so I have a line here and a line above it, and then my real data in a different color, in a different style, that is in this real curve. Okay, so that I can now measure that slope, and then I can measure this slope, and I can measure this slope, and I can see how much my data is fluctuating from the slope. So accounting for all the data, looking through all the process, I'm seeing that this slope, let's imagine that the one slope is 9.8, but my more steeper slope, my potentially, due to my uncertainty, my potential maximum value there is something like 12.1. And my minimum here, we're going to say, is something like 7.3. That's just me measuring the slopes of my greatest incline, my shallowest incline, and then the one that represents my data. Okay? So in another way, I am looking at the error associated with my data itself. Cool? A couple things. Like I said, make sure that this is 0, 0. Do not crop your data. Make sure that it's your tables are labeled, your axes are labeled, distance, time, and then you should also label your entire graph. In this case, it's what, y versus x, so that would be distance, our displacement versus time squared. Okay, make sure that your graph is labeled. Cool. And if you feel like it, you can below here say that this is my slope, this is my max slope, this is my min slope, but it's actually not as important as you think, because we're going to talk about that in a second.